Hi, good morning everyone. Welcome over definite integral exercise using properties. So here in this first question that I given for the today's assignment, so I will discuss some question here from that. So like in this your first question, first part, so how you will solve that one. If you have modulus is given to you, like this question is 0 to 6 modulus x minus 2 dx is equal to 10. If this is given to you, so first you have to think, you apply the here chain property of definite integrals. First you have to think which term of x lies between here 0 to 6. So you just pick left hand side, so that is 0 to 6 x minus 2 modulus dx. So here, so what you will do, this x minus 2 is equal to 0, that means x is equal to 2. So that means that x lies between 0 to 6. So first you open like the modulus of this, because this is your fx function here. So when you apply the property here, so that gives you first 0 to 2 modulus x minus 2 dx plus 2 to 6 modulus x minus 2 dx. Now modulus means both negative and positive sign, consider it here. So if this lies between 0 to 2, that means upper limit is 2 and inside modulus is x minus 2, that means that term if you draw on the graph, so that term has to reach up to 2 but not crosses the 2. So but that term x is equal to crosses the 0. So if it crosses the 0 but not crosses the 2, but actually my inside term is x minus 2, so we have to think about the 2, whether it crosses the 2 or not. If it not crosses this term, so that will be considered as your negative sign. So when modulus is removed here, so that will be considered as x minus 2 dx, and here will be 2 to 6. Now 2 means the lower limit is 2, it crosses the 2 and it has to reach to till x, so that will be positive sign when you remove the modulus sign. So that will be 2 minus x, and your integration 0 to 2 dx, and here also like x minus 2 2 to 6 dx. So we have a linear factor, we can solve this as my linear factor condition. Like here we consider as power 1. So when you integrate this one, 2 minus x raised to power 1 plus 1, and that is also in the denominator, and differentiation of 2 minus 1 is minus 1 accompanied with that. So this limit now shifted to this side. Here also x minus 2 1 plus 1 1 plus 1, then x minus 2 differentiation is 1, so that we write it the denominator, and if it is 1 no need to write, because understood that if any term multiply with 1, that is the same term. 2 to 6. So if you solve this one, so this will be 2 minus x raised to power 2 and minus 2. Okay, then here 0 to 2, but here when you apply it here, so that will be your x minus 2 by 2. You can take out constant term outside before applying the upper limit or lower limit. So here when you take this as common, so 2 minus x square 0 to 2 plus 1 by 2 x minus 2 square, that is 2 to 6. Now you apply the first upper limit, then lower limit. Minus 1 by 2, that minus 1 by 2, and here when you apply first upper limit 2 minus 2, so that become 0. Now minus, now you apply the lower limit 2 minus 0 whole square, and here also 1 by 2 6 minus 2 whole square. First apply upper limit, then lower limit, so this becomes 0. So only it is left 2 square is 4, then minus 1 by 2 is already outside, then minus 4. So that will be plus 4 by 2 plus 1 by 2. 6 minus 2 is 4. If 6 minus 2 is 4, 4 square is 16. So that will be 1 by 2 into 16. So what I will do, and this will be 0. So all the term has 2 as denominator, so it will be easier for me to add this one. So here it is not 1 by 2, because this will be multiplied with this give me 4 by 2, and this 1 by 2 multiply with this 16. Now you take the LCM as 2, 4 plus 16, then 20 by 2 is equal to 10. So that is equal to exactly your right hand side. So this type of the modulus question you have to solve. Now next question under this is like of same type, like first and second part is of same type, and third and fourth part is of same type. So I will discuss here your third part. So I will go with the fourth, that is the same type. First is also included in that. So either you go with the third and fourth, condition is same. So I solve it here, third part, because third and fourth is of same type. In third question you have to apply the property here. So here you have given 0 to pi by 2 sine square x dx is equal to 0 to pi by 2 cos square x dx, that you want to prove. So statement of that means either you will take this statement or either you will take this statement. Your answer will be pi by 4. So what I will do, if I solve with both the cases, like sin square x dx and 0 to pi by 2 cos square x, but in your fourth part you have tan cot is that first you open this, take the LCM, then apply the same concept here what I am applying here. So here you have to solve both the terms, then you check whether both will be equal to pi by 4 or not. First you have to solve this one, 0 to pi by 2 sin square x. So if I take it, I draw the line here to check this one. So I will take separately 0 to pi by 2 sin square x dx. Now this I consider as equation 1. Now apply the property a minus x property here. So this I consider as I. So if I apply the property here, so if I applied the property here a minus 1, that becomes 0 to pi by 2 sine pi by 2 minus x whole square dx. Sin 90 minus theta give me cos theta. So that will be I is equal to 0 to pi by 2 cos square x dx. So that is your second equation. Now when you add this one, first and second equation here, so that becomes by adding equation 1 and equation 2. So that give you 2i, and here when you add this one, 0 to pi by 2 sin square x plus cos square x. I write it common because same limit is there here, and dx. Sin square x plus cos square x is my identity, so that gives me 1. So pi by 2 1 dx. Now you have to integrate. Integration of 1 is x, so that gives me 0 to pi by 2. Okay, so here when you apply this, so only pi by 2 is left. My required I value is equal to pi by 4. Now come to this second part. You have to check about 0 to pi by 2 cos square x also. So go with same condition. Your I is equal to 0 to pi by 2 cos square x dx. Apply again a minus x property. So this will be considered as equation 1. So 0 to pi by 2 cos pi by 2 minus x, because square is on the cos, not the angle. So this will be taken at common. So then I is equal to 0 to pi by 2 sin square x dx. So this is your second equation. Now you have to add these two equations So adding equation 1 and 2, so that gives you 2I is equal to 0 to pi by 2. Same thing here. Then sin square x plus cos square x dx. After that all conditions will be same. 2I is equal to 0 to pi by 2 1 dx. Then 2y is equal to x 0 to pi by 2. Then after solving I will get pi by 4. So that means whether you take sin square x or whether you take cos square x, your answer will be in both the cases is pi by 4. Now in this, your next type of question is question number 5. 5 and 6 is of again same type, so I will go with the 6th part. So here in the 6th part you have 0 to pi x f sin x dx is equal to, that you want to prove pi by 2 0 to pi f sin x dx, that you want to prove in this case. Okay, so if I just pick left hand side it here, so that give me 0 to pi x f sin x and dx. Now I will try to apply the formula of again your property of a minus x here. So we will consider as my equation number 1, because I want to prove that that will be pi by 2. Left side should be equal to the right hand side, that I want to check. Okay, so I just apply the property here. So I is equal to, before applying the property you mark this as equation 1. In place of x I write pi minus x f sin pi minus x here, so dx. So you very well know that sin 180 minus x lies in second quadrant, sin is positive, so that will be remain as sin x. So according to that your second equation will be here. So I is equal to 0 to pi minus x, so that will be same as f sin x dx. So now you open this one, so this is your second equation. Okay, if we open this one, I is equal to 0 to pi, so I will take pi here, then it will be like f sin x, because I open it and separate the terms, like minus 0 to pi x, then f sin x and dx. So that will be there. If you look at this, this is same as my original equation here I. So what I consider as equation 1. So in this equation 2, if I just replace the value of this, so pi 0 to pi f sin x dx minus I replace this as my original equation as I. When I shifted on this side, so that will be 2I into pi 0 to pi f sin x and dx, 0 to pi f sin x dx. So that will be my required condition. So here if you shift 2 on this side, so I is equal to pi by 2 0 to pi f sin x dx. So that is exactly equal to right hand side that you want to prove in this. So that is exactly equal to your right hand side. Now your 7th part question is here 0 to pi by 2 log tan x plus cot x dx, that you want to prove that will be pi log 2. So what I will do, I just pick this left hand side here, left hand side. So 0 to pi by 2 log, when you open this one, so this is sin x by cos x plus cos x by sin x dx. Now when you take the LCM of this one, so this will be I is equal to 0 to pi by 2, because if you apply here pi by 2 minus x property, so that condition will be same again. So instead of this we will open this tan x and cot x, so that will be give me log sin square x plus cos square x if I take the LCM, and denominator is sin x and cos x dx. So what I will do, I just apply the formula here. Identity formula is 1. So 0 to pi by 2 log 1 upon sin x cos x and dx. Now apply here my log m upon n rule is log m minus log n. So I apply it logarithmic concept, that is log 1 minus log sin x then cos x. So that I apply it here dx. So log 1 value is 0, so only this much is left. Log 1 value is 0, you take it minus common outside, 0 to pi by 2. Here if you think that this is log m into n, I can again open it log sin x, because minus I take it common outside, so that becomes, according to the logarithmic rule, log m into n is log m plus log n. So that is log cos x dx. So when you further solve this one, I is equal to minus, you separate, keep negative sign outside as it is, 0 to pi by 2 log sin x dx plus 0 to pi by 2 log cos x dx. We have already formula of here. Here we no need to prove that. We apply the formula here. So that is 0 to pi by 2 log sin x formula is minus pi by 2. That is integration of this is minus pi by 2 log 2. And same formula is log cos x, because both conditions are same when you solve this. So this is also same is equal to minus pi by 2 log 2, that we already proved in our formula list. So we can directly apply it here, 0 to pi by 2 log sin x dx. So we will take minus common, so that become positive, and we will take log 2 common also, so that gives me pi by 2 plus pi by 2. So 2 pi by 2 gives me pi. So my required answer will be pi log 2. So that is exactly equal to your, right hand side. So this question you have to do this way. So I repeat it again, log tan x plus cot x. If you try to apply the property here, a minus x property, so what will happen? So question will be exactly same. So there is no change in the question. So in that case, first we will open tan x and cot x as sin x by cos x plus cos x by sin x. Then we take the LCM, sin square x plus cos square x, we use the identity here, that is 1. And denominator is sin x cos x, 1 upon sin x cos x. When you apply log m upon n concept, log m minus log n. Log m is 1 and this is log sin x cos x, that is n, in the place of n is there. Now log 1 value is 0, so I directly shifted to here minus 0 to pi by 2. I apply again the logarithmic concept, log m into n, that is log m plus log n, log cos sin x plus log cos x. Now if you separate the limit, you have formula 0 to pi by 2 log sin x dx. We already proved this in the class, minus pi by 2 log 2. Here we directly apply the formula here, minus pi by 2 log 2. So you take log 2 common, so that will be required answer, pi log 2 is equal to exactly right hand side. Thank you.